In today's lesson, we're going to be looking at sequences. So you're just going to be looking at some simple notes, examples, as well as some exam tips. So let's start with defining a sequence. What is a sequence? A sequence is going to be a list of numbers that follow a particular pattern or a rule. That is how we define a sequence. For example, 2, 4, 6, 8, 10, 3, 6, 9, 12. Those are some examples of sequence. It's just a list of numbers that are following a particular pattern or a particular rule. And each number is called a term. So looking at the numbers that we have in our example, 2, 4, 6, 8, 10. 2 is a term, 4 is a term, 6 is a term. So we call them first term, second term, third term, fourth term. So we are saying that 2 is the first term. 4 there will be the second term. 6 will be the third term. 8 will be the fourth term. 10 will be the fifth term. And the position of a term is represented by the letter N. That is going to be what you call a sequence. So now, how do you find the next sequence if it is going to be a sequence? So for example, here to find the next term, you're going to be looking for the pattern between the consecutive terms. So in this case, we've got 3, 7, 11, and 15. You're looking at 3 and 7. What kind of pattern is there? You're looking at 7 and 11. What pattern is there? 11 and 15. What pattern is there? So you're going to look for the pattern between the consecutive terms. So if you look from 3, so since we've got 3, 7, 11, and 15. From 3 to 7, there's a difference of 4. You add 4 to get to 7. To go from 7 to 11, you add 4. To go from 11 to 15, you add 4. So it must mean that the next term after 15, you just add 4, which will be 19. So that is going to be how we find the next term. If you are given 20, 17, 14, and 11, that's another example. Again, you are going to look at the pattern that exists. From 20 to 17, there's a difference of 3. To go from 20 to 17, you remove 3. To go from 17 to 14, you also remove 3. To go from 14 to 11, you also remove 3. So what is the next term? The next term will be 11 minus 3, which will be 8. So that is how we find the next term. Then we are going to move on to the types of sequences. So we've got what we call an arithmetic sequence. So we say that an arithmetic sequence is the same difference between consecutive terms. So for example, in this case, to go from 5 to 9, from 9 to 13, from 13 to 17 to 21, the difference is the same. So when it comes to arithmetic sequences, you're using two symbols, a plus and a minus. It's either you're adding or you're subtracting. So to go from 5 to 9, 6, 7, 8, 9, we add 4. To go from 9 to 13, you also add 4. So that's why we are saying that in arithmetic sequence is the same difference. In this case, the common difference is going to be 4, which is now going to bring us about the nth term that you mentioned. So to find the nth term, we're going to be saying Tn is equal to a plus n minus 1 d, where Tn is the nth term, a is the first term, n is the term number, and d is the common difference that we're talking about. So now we have got an example question. So here we are given, let's say that we are given these values. You are given 4, 7, 10, and 13. And then the question says that find the nth term. For you now to find the nth term, you've got your 4, 7, 10, and 13. You're going to be using this Tn is equal to a plus n minus 1 d, where a is the first term, which is 4, plus n minus 1. We don't know what is n, so it's just going to be n minus 1. Then d is the common difference. To go from 4 to 7, we add 3. From 7 to 10, we add 3. From 10 to 13, we add 3. So the common difference is 3. So now we've got 4 plus bracket n minus 1 times 3. So what you're now going to do is that you're now going to multiply the bracket by 3. So 3 times n, that is 3n. 3 times negative 1, that is negative 3. Then now we are going to collect the like terms. So 4 minus 3 plus 3n. If you say 4 minus 3, you get 1. So now you've got 1 plus 3n, which we can now rewrite it as 3n plus 1. So now we are saying that Tn is equal to 3n plus 1. So we found the nth term. That is how we find an expression for the nth term. But what if we are finding a particular term, not just the nth term? Because here the nth term, we don't have a specific value. But now what about if for n we've got a particular value? How are we going to go about that one? So now we are saying that if you are now looking for a particular term, let's use the one that we found and say that Tn is equal to 3n plus 1, right? And then let's say that you are told to find the 10th term now using this same sequence. You're asked to find the 10th term. So where there is an n, you're going to put 10. So it becomes T10 is equal to 3n, which is 10 plus 1. So 10 times 3, that is 30, plus 1, that is 31. So our answer is now going to be 31. Okay, and then for the next thing that you're going to be looking at now, okay, so here we're looking at a particular term. Let's look at how to find the nth term from a sequence. So now let's actually look at how we can find the nth term from a sequence. So let's say that, let me just erase everything here. Let's say that we've got our sequence. We've got 7, 12, 17, 22, and 27. So the first thing that we are supposed to do, since we are trying to find the nth term of 7, 12, 17, 22, and 27, we are supposed to know your A as well as your D. So let's find D. D is the common difference. What is 12 minus 7? That is going to be 5. What is 17 minus 12? That is 5. 22 minus 17, 5. 27 minus 22, that is 5. So to go from 7 to 12, you add 5. From 12 to 17, you add 5. So the common difference is 5. So now, what you are going to do, because here we are trying to find the nth term from a sequence. So instead of using the formula, so you're saying that to find the nth term from a sequence. So now this 5 that we just found, you're just going to say 5n. Okay, you're just going to put a 5n. And then after that now, you're now going to compare. So that is the second thing that you're going to do. So the first thing we did was to find the difference. Then now we are going to compare. So you're going to write your n. Then we've got our 5n. Then we've got our sequence. Right? So the first term is 7, 12, 17, 22, 27. 7 is at 1. It's at position 1. It's the first term. 12 is the second term. 17 is the third term. 22 the fourth term. 27 the fifth term. So now what is the importance of this part where there's a 5n? You're just going to multiply because we know that n is 1. So what about 5n? It will be 5 times 1. Here it will be 5 times 2. 5 times 3. 5 times 4. 5 times 5. So as you can see, if you were to look at what we have right here, it went from 5 to 10, from 10 to 15, from 15 to 20, from 20 to 25. So we're saying that the sequence is always 2 more. If you notice, it's always going to be 2 more. Because we've got from 5, then you move on to 10. Then you've got from 10 to 15. So it's always going to be 2 more. So now we can say that Tn is equal to 5n plus 2. Something like this here. Or we could have just used the original method, the first method that we looked at. So let's try to see if the answer is going to be the same. So we've got our a plus n minus 1 d. Our a, we said that it's going to be 7 plus n minus 1 d. That becomes 7 plus 5n minus 5. So 7 minus 5, that is 2. So that is 2 plus 5n. So the answer is still going to be the same. We are still going to get 5n plus 2. Then you're also going to have negative differences. So here we are looking at positive. For example, we are saying that our d is positive 5, positive 4, positive 3. So here was 30, 26, 22, 18 and 14. The difference from 30 minus 26, that is a 4. 26 minus 22, that is a 4. 22 minus 18, a 4. 18 minus 14, that is a 4. But to go from 30 to 26, we remove 4. To go from 26 to 22, we also remove 4. To go from 22 to 18, we remove 4. From 18 to 14, we remove 4. So the difference is a 4. So now we know that we are starting with negative 4n. So what about if n is equal to 1? So we're saying that if n is equal to 1, we're now going to be left with a negative 4. But the first term that we have is a 30. So now we are going to say 30 minus, we are subtracting, so 30 minus, right? Then you say minus the difference, which is now going to be equal to 34. Therefore, we're now saying Tn is equal to 34 minus 4n. But if you don't understand this method, you can also use the other method that we looked at, which is for using the formula. So you can just use the formula instead. A plus n minus 1 d. 30, which is the first term, plus n, which is the, we don't know what is n, minus 1 times d. D is the common difference. So now we've got 30, n times negative 4, minus 1 minus 4. So now we've got 30 plus 4, which is 34, minus 4n. So the answer is going to be the same there. We still got the 34 minus 4n. Then now we are going to have what you call geometric sequences.